Hi, so this is Alex Scroval, and I'm doing my part 3 to my oral exam. So we're going to start off by talking about L'Hopital's rule. And so with L'Hopital's rule, sorry, I'm really bad at pronouncing it, tells us that as the limit approaches x, that the limit is a 0 over 0 function. So if you can see this, so when you have say a limit is x approaching a constant that equals 0, to use L'Hopital's rule, you need it so that your f prime over your g prime also equals some constant. So it has to be either a 0 over 0 function, your original function, or it has to be a infinity positive or negative over another positive or negative infinity. So here's one of my examples. So as the limit of 2x over x goes to 0, both of them will be heading towards the 0 directions. But if you take the derivative of both of them separately, which you do with L'Hopital's rule, you actually get f prime of x equals 2 and g prime of x equals 1, so the actual answer is 2. So that's how you use L'Hopital's rule. I'm going to be moving on to question 2, which is consider the following function and what happens if you put a rectangle inside of an ellipse. And what is the max area of that said rectangle. So step 1, I drew out my graph, which is here. And then I would find the area of my rectangle, which I got to be 4x. And then my next step would be to differentiate the area with respect to x, the area of the rectangle in respect to x. Then for step 4, I would differentiate the equation of the ellipse with respect to the x value. Then for my step 5, I would put the value of my dy over dx from step 4 into my equation into step 3 equation. So it would be just compounding your equation for your area into your equation of your ellipse and plugging them into each other after you're done differentiating both of them separately. So after you do that, for your step 6 is to be putting all of those y values into your equation for step 5, and that's how you find your max area of your rectangle. So my next one is question 3, and it's a little bit more complicated to explain for me. So I used a equation. So I'm missing a paper. Actually, no, I'm not. Never mind. So I made up this equation and did some random condition. So I use f of 0 equals -1. Your step 1 is to integrate with respect to x. So that's what I did. Here's my step 1, so dy over dx, and then I kind of skip some steps so it just makes it a little bit cleaner on the paper, and that's me integrating it. And after that, so you do your integration. You plug in, so then after you're done integrating, you add your c value, which is your constant. So because if you do if you try to take a first derivative test, you always lose your last value of your digit at the end. So when you're integrating to find your original equation, you need to add that constant back on. So that is your c value. So then you for step 2, you set your initial condition into your equation. So this is what I did. So f of 0 equals this, and then to the -1. So then you find your c constant, and then you take that and you plug it into the original function. So for our part 2 of it, which is how do you find your original function if you have the second derivative test. And so what you would do is kind of the exact same steps, just twice. So you would integrate, and then you would use your first derivative's initial condition, and you would reintegrate back into it to find your constant value in that equation, and then you would do the exact same steps again and then using your initial condition of your original equation to find your original equation. So for question 4, which is what makes something a critical point within the study of calculus? For calculus, the critical points are the points at which the first derivative of the given function vanishes at the critical point. So as an equation standpoint, it is when your f prime of x equals 0 or your f of x doesn't exist. So when your equation is going up towards some point and it vanishes off of your point. So that is your critical point of your equation. Thank you.